Hi, welcome. This is a lesson on simplifying radicals, and we're going to go ahead and just jump right in. Um, One of the things that will be important is a property of radicals that says that if I have the square root of a times b, that's equal to the square root of a times the square root of b, and so we can consider separate factors separately. So on simplifying radicals, first off, we'll say um, for the coefficients under the radical, write the prime factors. Okay, so let's look at example one. Was we're talking about that 96, and the prime factors. You can use a factor tree like you might be used to. This is maybe a slightly different way, but it's basically the same way. I start with the smallest prime factor, which is 2, and 2 goes into 96 48 times. And so long as it's even, I can keep dividing it by 2. So 2 goes into 48 24 times. 2 goes into 24 12 times. 2 goes into 12 6 times. And 2 goes into 6 3 times. And 3 is prime. When you get to a prime number, you're done. So the prime factorization of 96 is 2 1 2 3 4 5 times 2 times 2 times 2 times 2 times 2 times 3, and then x to the fourth is x times x times x times x multiplied by itself 4 times. And then let's go ahead and say also write in expanded form the variables. Or write the variables in expanded form. Then take out groups. That are equal in number to the index of the radical. Remember that the index of square roots is 2. Okay, so the number that would be there if there were a number there is 2. So we're looking for pairs of factors. So I've got one pair of 2's, another pair of 2's, one pair of x's, and a second pair of x's, and each of those is going to come out as an individual factor. The square root of 2 times 2 is 2. That's the single pair of their 2's. And then the square root of 2 times 2, the second pair, that's also 2. And then I've got x times x. And so what that looks like is that this pair of 2's came out as a single 2. This pair of x's came out as a single x. And this pair of 2's came out as a single 2. And this pair of x's came out as a single x. And you'll notice we still have this 2 times 3 stays under the radical, so it's square root of 6. And then everything gets multiplied back together. 2 times 2 is 4. X times x is x squared. And then I have the square root of 6. All right, let's look at the next one here. So 162. I say 2 goes into 162 because it's even. 2 goes into there 81 times. Excuse me. And 81 is not even, but you can divide 81 by 3, and 3 goes into 81 27. I'm going to 3 because it's the next biggest prime number. And if you add the digits 8 plus 1, that's 9. 9 is divisible by 3. Therefore, 81 is divisible by 3. And it goes in there 27 times. 3 goes into 27 9 times, and 3 goes into 9 3 times. And then I'm going to write this out here. So I've got 2x, and the index is 3. That's the cube root of 2 times 3 times 3 times 3. There's 1, 2, 3, 4 3's times 3 times x to the 7th times x times x times x times x times x times x. How many is that? 1, 2, 3, 4, 5, 6. One more times x to the 7th. And this time, rather than looking for pairs, I'm going to be looking for 3's. So I have one group of 3's, one group of x's, another group of x's, and those are going to come out as single units. And so everything else is going to get multiplied and stay under the radical. So 2, 3, and then that other x is going to stay under the radical because we don't have a group of 3 with them. So we have 2 times 3 times x times x times x times the cube root of 2 times 3 times x. And so these 2, 3, and x are the yellows ones up above. And this 2x here is this 2 and one of those x's. And then there is from the group of 3 that came out and the individual groups of x's that came out as well. And so now I just multiply that all together. 2 times 3 is 6. X times x times x is x to the 3rd power times the cube root of 6x. And that would be how this looks like when you simplify. Okay, example 3. We've got 45. So over here, I'm just going to go over real quick. 42 won't go into 45, but I always check. 45 is not even, so 2 won't. But then I go to the next prime number that's bigger than 2, which is 3, and 3 will go into 45, and it goes in there 15 times. 3 goes into 15 5 times, and 5 is prime, so we're done. We're once again looking at this being an index of 2 because it's a square root. So I'm going to write this out as 3 times y times the square root of 3 times 3 times 5 instead of 45. X cubed is x times x times x times y times y times y times y. And now I'm going to circle this time. I'm just going to circle. There's a group of 3's. There's one group of x's. There's one group of y's. And there's another group of y's. So all of those are going to come out as individual factors. So I got 3 times 3 times x times y times y times y. And then under the radical, we're left with 5 and x. 5 and x. And so 3 times 3 is 9. X. Y multiplied by itself 3 times, y cubed, times the square root of 5x. And that's the simplified form of this radical. All right, let's look at the next section is on complex numbers. A complex number is in standard form is written as a plus bi, where a is the real part and bi is the imaginary part. When adding or subtracting complex numbers, we combine real parts and we combine imaginary parts. But we don't combine imaginary parts with real parts. This is why we call them imaginary parts. The square root of -1 is I, because if you think about the square root of 9 is asks the question, what number multiplied by itself 2 times is 9, and that would be 3. But if I were to ask you, what is the square root of -9, you might say +3, but we already know that 3 times 3 is +9, or you might say -3, but a -3 times a -3, where a negative times a negative is also positive. Is not -9. And so there's no number in the real numbers that when you multiply it by itself, you would get a negative number. So we came up with this imaginary numbers set that if I've got the square root of -1 is equal to I, then I squared is equal to -1. If I multiply I times I, I get -1. All right, let's look at example 4. The square root of -25. I can rewrite this. Remember what we talked about at the beginning, that I can rewrite the square root of a product as the product of square roots. And so the square root of -25 is the same as the square root of 25 times the square root of -1. And then the square root of 25 is 5, and the square root of -1, as we just talked about, is I. All right, let's look at example 5. So it's got the square root of -16, a cubed, b to the 4th. And remember that we're looking at an index of 2. So we're going to write this out as the square root of 2 times 2 times 2 times 2 is 16 times -1 times a times a times a times b times b times b times b. And then I'm going to circle pairs. There's a pair of 2's. There's a pair of a's. There's a pair of b's. There's a pair of b's. And the square root of -1 is going to come out as I. So we've got 2 times 2 times A times B times B times I times, the only thing left is that A. So we've got the square root of A. And 2 times 2 is 4. A, B squared, I, square root of A. And we don't want to write that I after the square root of A because we might get confused and think that it's under the radical. So this is what that looks like. And then we've got -7 times the square root of -72 x cubed y to the 4th. So let's go over here to the side, 72, and write out our factors. 2 goes into 72 36 times, 2 goes into 36 18 times, 2 into 18 9 times, 3 into 9, 2 won't go into 9, but 3 will, 3 into 9 3 times, and so then I can rewrite this as 1, 2, 3 2s, so that's 2 times 2 times 2, 2 3s times 3, and times the square -1 times x times x times x times y times y times y times y. Once again, this is a square root, so the index is 2. So I've got 1 pair of 2s, 1 pair of 3s. That -1 as a square root is going to come out as an I. 1 pair of x's and 2 pair of y's. So I can bring all of that out, and it's going to be multiplied by this -7 out front. So it's -7 times 2 times 3 times x times y times I. And there is a 2 and an x that are going to stay under the radical. And so that's 2x. And then I multiply it all together. -7 times 2 times 3. 2 times 3 is 6 times 7 would be -42. X, y squared, I times the square root of 2x. And that's what this looks like.